This is chapter number 6, equations, vectors, and formulae. When we talk
Mm-hmm.
about equations, it is an algebraic expression and an algebraic sentence, rather, which involves the equality sign. So, and when we talk about linear, the word linear means that the power of the variable is 1. So, when I say that 2x plus 3 equals to 5, for example. So the variable is having power 1 and there is an equality sign. So that's why this would be a linear equation. Then when we need to solve a linear equation, by this keyword solve, we mean to find out or to work out or to dig out the value of the variable
Uh-huh.
that
Okay.
satisfies the given equation. For example, from the above equation, if we solve it using algebraic techniques, I need to shift this 3 to the other side of the equality, and
Okay.
that would be 5 minus 3, that is 2. And now shifting this 2 to the other side, it will get divided. 2 divided by 2, that is 1. So the value of the variable x is 1. That means if we substitute this value of x, the variable, into this equation, 2 times the value of variable x is 1. I replaced the value of x to be 1. Don't get confused with this one. This was actually the power of x, and now this is the value of variable x, and then plus 3. Do we have the same answer of this side of the equation as is on the other side, that is the right hand side of the equation? So let's see. Now this gives 2 times 1 is 2 plus 3. The answer is 5. Yes, that is equal to the right hand side of the equation.
Okay.
We started off with left hand side, and that left hand side of the equation is compatible or satisfying the right hand side of the equation. So that means this equation is satisfied for this value of x. So uh, this is what we mean by solving an equation, to find out the value of the involved variable that makes the given equation true.
Mm-hmm.
Okay.
Okay.
Then uh, we proceed further.
Mm-hmm.
There are some rules of solving equations. The rules are normally that if one number is being added on one side of the equality,
Mm-hmm.
when it will be shifted on the other side of the equality, that will get subtracted. If a number is being multiplied on one side of an equality by a number, when that will be shifted on the other side of the equality, that will get divided, and vice versa. Like if a number is being divided, like if it would have been x divided by 4, and on the right hand side of the equality, if we need to shift it on the other side, it would have got multiplied, provided that on the left hand side we have got a single fraction with a single denominator. And similarly, if a number is being subtracted on this side of the equality, when we will be shifting that number on the right side, that will get added. So with these rules, let's start solving some of these equations. 4 times the variable x plus 3 equals 31. So first of all, we need to shift this 3 to the other side. And the motive is why we are shifting all these. The thing is that we need to make the variable x the subject. Subject
Okay.
means to be solitaire with coefficient 1. Like you need to make x a separate and only one variable to be retaining on one side of the equality, and you need to shift all other terms, all other variables, everything else on the right side or on the other side of the equality. So that is what is the meaning of making the variable subject one thing, and that is
Mhm.
to find out the value of the variable, and that is what we mean by solving an
All
equation.
right.
So our motive is to shift every other variable, every other constant on the other side of the equality, making the required variable the subject of the equation. So let's begin now. We first of all need to shift this plus 3 to the other side. That will get subtracted. So we would be having 4x equals to 31 minus 3. That will give me 28. And on this side, I'm left with 4x. Now, since I need to make x the solitaire, I need to shift this 4 to the other side of the equality. 4 is being multiplied with the variable. So when it will be shifted on the right side, it will get divided with whatever is there already on the right side of the equality. So you see that I have divided 4 on the other side. So
Okay.
x equals to 7. 4, 7 times 28. So this is actually showing that when we will be substituting the value of variable x to be 7 in the left hand side of this equation, we would be getting answer 31. So we can check it out, though this is not the requirement of the question, but sometimes question may ask, check your answer, whether your answer is correct or not. So this is how we check it. We take the left hand side or even any one side of the equality. I am taking its left hand side, which is 4x plus 3, and 4 times, now I'm going to replace this value of the variable x, that is 7, plus 3. 4 times 7 is 28, and when you add 3 to that, you get 31. Yes, that is equal to the right hand side of the equality. That means our answer is correct.
Okay.
Okay. With this thing now, um, let me solve some other question, like part F could be solved, which involves a constant number which is being subtracted. So 11n, I'm going to shift this negative 19 to the other side. It will get added now. 121 is equal to 11n. And now I need to make n the solitaire or the subject. For that, I need to shift this 11 to the other side of the equality. Since on the left hand side at the moment, this number 11 is the coefficient of the variable n. That means it is being multiplied with the variable n. So when it will be shifted on the right hand side, it will get divided with whatever is there already on the right hand side. So that gives me 11. 11s are 121. So the value of the variable n is 11. That means we have solved the equation.
Mm-hmm.
Okay. Now let's proceed to a bit of more uh, complex sort of equations. In this type, like question number 2, you see that there is one expression on the left hand side of the equality and a same kind of an expression on the right hand side as well. Now in this case, we are not having only a constant number on the right side as we were having in question number 1. So how
Yeah.
we would be solving them up? Okay, let me pick up part C, for example, the method is that to shift like terms on one side of equality. Okay, now for this is 6y plus 1 equals to 3y minus 8. What I'm going to do, since y terms are the like terms, so I'm going to shift this term to this side. So that will make me to have 6y minus 3y, because it is a positive term already on the right hand side of the equality. It got shifted to the left side and got a change of sign. And on the right side we are already having negative 8. But where has this 1 gone? I'm going to apply the same procedure. This 1 is already being added. When I will be shifting this to the other side of the equality, it will get subtracted. So minus 1 will be there. Now on the either side of the equality, you see and observe that the like terms are there on each side. On the left hand side, we have got two terms involving variable y, and on the right side, we are having pure constants. So 6y minus 3y, that will give me now 3y, and on the right side, negative 8 minus 1 is going to be negative 9. So now 3 is to be shifted on the other side of the equality, this 3.
Mm-hmm.
So since it is being multiplied with variable y, when
So
I'll be
we
shifting it on the other side, it will get divided. So
-3.
yeah, so the value of variable y is negative 3. So this is how we check the solution. This is how we do the solution. We haven't checked the solution yet. If it is the requirement of the question, we can do it as we have been doing in the previous cases. Or like, for
Yeah.
example, okay, let me solve this one for checking as well.
Oh no, I get it.
Yeah.
Okay.
Uh, okay, the value of y was negative 3. 6 times, now I'm having its left hand side, that is this one, negative 18 plus 1, that is negative 17. And what about the right hand side? Are we getting the same answer? Let's see. That is 3 times negative 3 minus 8. So negative 9 minus 8, that is negative 17. Yes, we are getting the same
Mm-hmm.
answer. That means our answer is correct. Okay. Now, if I could do its part F, that involves a fraction. The method is exactly the same, but let me do it. 1 by 2x, and this is the x term on the right side, so I'm going to shift it on the left side, and this is a constant. I'm going to shift it on the right side. So this is going to be done like this. Uh, when we will subtract quarter from half, we would be left with another quarter. And on the right side, this is 15. Now we need to observe that the variable x is there in the numerator and the
Mm-hmm.
constant number 4 is there in the denominator. Or we can say that the variable x is being divided by 4. So
Okay.
I need to shift now this 4 to the other side of the equality, and as I told you earlier, a number that is being divided or that is there in the denominator, when it will be shifted on the right side, it will get in the numerator. So 15 times 4, and the value of x would be like this. This is 16. So this is how we solve it.
Uh-huh.
Okay, now I come towards solving some other questions. Let me pick part F of question number 3 as well. It involves another step, that is, first of all, we need to multiply this negative 2 with this term. So that will give me negative 2 times x is negative 2x. and then this negative times this positive is negative.
Mhm.
2 times 2, that is 4, and on the right side 4x plus 9. Now this question is just similar to this question number 2. Now we need to combine the like terms. So negative 2x, I'm shifting this to this side, negative 4x, and positive 9 is already here on the same side, but I'm shifting this negative 4 to the other side. It will get added. So this is negative 6x plus is equal to 13. And the value of x, now you need to observe that when I'm shifting this negative 6 to the other side, you need to observe that
Uh-huh.
the coefficient of x is negative 6. It is not x minus 6. If it would have been x minus 6, when we would have shifted this minus 6 to the other side, that would have given us 13 plus 6. But since this isn't the case, in this case, we have
Oh,
got negative 6
uh,
being multiplied with the variable x. So when it will be shifted on the right side, it will get divided. But there, in this case, there will be no change of signs. You need to observe this thing.
oh, okay.
When this is the shifting of multiplied number to be shifted on the right side, it goes on the other side with the same sign.
Mm-hmm.
Yeah. So negative 13 by 6 is going to be the answer.
Okay.
Okay, then I proceed towards some next question. Question number 4 is just similar to this one, but it now involves multiplication uh, at 3 different stages. This is to be multiplied with this one, this is to be multiplied with this one, and this is to be multiplied by this one. And then we need to combine the like terms. Okay, let me pick up part F, or let it be some other alphabetical part. You might not be thinking that I choose part F all the times. Let it be part G. Now 2 is
Okay.
to be multiplied with p to give me 2p. Then 2 is to be multiplied with negative 1, that gives me negative 2. Now negative 7 times 3p is negative 21p, and then negative 7 times negative 2, that is positive 14. Yeah, and on the right side 7p minus,
Seven,
yeah,
28.
this one, this one. So now we observe that the p terms are there, 2p minus 21p, and I am going to shift this p to this side as well. So negative 19p and then
Mm-hmm.
minus 7p, and then negative 2 plus 14 is actually positive 12, and negative 28 is already there on the other side of the equality. Solving these two, I get positive 12, and now this will be shifted to the other side, that will get minus 12.
Okay.
So now,
Negative 26p
yeah,
equals.
now as I told you earlier, you need to shift now this negative 26 to the other side. So when it will be shifted on the right side, it will be having the same sign with it. So now we can cancel this negative sign with negative, and now we can cancel them up on uh, table of 2.
Okay.
Yeah, 20 divided by 13, or you can further divide them to have the answer uh, in a proper fraction as well.
Mm-hmm.
Like, yeah, the answer could be 1 whole 7 by 13, or even you can give the answer in decimals. So all of them are correct. Okay, now I proceed to question number 5 that involves fractions.
Okay.
Uh, there is a bit of difference that I want to clarify in part A. If you observe part A, D, E
Mm-hmm.
are alike, and part B, C, and F are of different type. The difference, if you notice, is that uh, in this type, there is only one fraction on the left hand side of the equality. A single fraction is there. But
Mm-hmm.
in this type, we have got a fraction with a separate number or a constant. So
Okay.
the difference is when we would be solving them, in all of these types, we can shift this 3 to the other side of the equality and get it multiplied with 8. This could be taken on the right side and 2 gets multiplied, and in this case we can take this 3 to the other side and get it multiplied with 3x. But it cannot be done directly in these parts because these are not containing the single fraction.
Okay.
So first of all, either we need to take this 1 to the other side and make a single fraction on the left hand side, or there is another way, like we can make it a single fraction right from the beginning by making its denominator same, like
Mm-hmm.
multiplying and dividing it with 3. So now you will see that the denominator is the same, that is 3, if you multiply and divide the second number with 3. So then you can shift this 3 to the other side. So in that case, it would not be just 1, it would become 3 here. So that is the difference that I've just explained. Let's see how we actually need to solve these questions. Let it be part E first, 2x minus 1. Shifting this 3 to the other side, it will get 3x times 3, that is 9. So 2x minus 1 equals to 9. Now shifting this minus 1 to the other side, 9 plus 1, and here we are left with 2x, and then this is 10, 9 plus 1.
Mm-hmm.
Where has this 2 gone? It has been shifted to the other side of the equality and got divided by 10. So the value of x is 5. So this is how we have solved this part. Solving means to find out the value of the variable. And now for, let me see its part B, uh, or C. Let it be the same part as I was discussing, part B. Method 1 could be that I shift this plus 1 to the right side. It will be 8 minus 1. So this is
Uh-huh.
7. And now I have got a single fraction on the left hand side. Now I can solve it as we did the previous part. 7 times 3, that is 21. And now I can shift this 2 to the other side so that the answer is 10.5. And for method number 2, if I adopt the second method, that would be to make the denominator same. 2x by 3 plus 1 equals to 8. Now I need to make the denominator same. That means 1 is already there in the denominator. I need to multiply it, the denominator, with the 3 as well as the numerator. Now I've got 2x over 3 plus 3 divided by 3 equals to 8. Now both the fractions have got the same denominator. I can have get it written only once, and now it is a single fraction. So now I can shift this 3 to the other side. That will be 2x plus 3 equals to 8 times 3, that is 24.
Mm-hmm.
And then I shift this 3 to the other side, that will give me minus 3.
Minus.
Yeah, and this is 21 now, and the value of x would be 21 divided by 2, that is 10.5 as before. So in both of the cases, you get the same answer.
Mm-hmm.
So now for question number 6, for example, this is all about just like as we did the previous question in which we were having uh, different terms on segregated on separate sides of the equality. Let me solve even part D for question number 6.
Okay.
Uh, Rather, instead of part D, let me choose part E because it has got 4 terms. So that would be involving a bit more working. So what
Mm-hmm.
I'm going to do, you need to observe this time. Okay, what's the changing that has been done? Only the shifting of terms. Okay, positive 1 by 5 got shifted on the right side, it got subtracted, and 1 by 5x got shifted on the left side, it got subtracted as well. Now, uh, to make their denominators same, because we know that fractions are always going to be added or subtracted when their denominators are same. So if I multiply this with 5 and this fraction with 3, what I would get? This will be 15x. This will also be 15x in the denominator. So then I will be able to subtract these two fractions. So this is going to be 15x in the denominator, and in the numerator it is 20 minus 3. And on the right side, this is the same thing that I need to do. 5 being multiplied here and 3 being
And you might.
multiplied by here. Yeah, to have the same denominator. Then this is
Mm-hmm.
20 minus 3. This is a coincidence that in this case, on the both side of equality, we have got same numbers to be multiplied, but this is not the case all the times. It might be like, for example, it might have 7 in the denominator, and on this side, I could have, like, for example, 11 in the denominator. Then I could have done
Mm-hmm.
it. This would have been multiplied with 11, and this could have been multiplied by 7 to have their common
Yeah.
denominators. So let it be this now. So 20 minus 3, that is 17 divided by 15x. And on the right side, this is 17 divided by 15. So what I can do is that uh, I can shift this 17 by 15 on the other side. Let me solve it here. 1 by x would be the same. 17 by 15, which is already on the right hand side. I first of all written it. Now let me change the color of my marker to differentiate. Now 15 is already there in the denominator. When I'm shifting it on the other side, it will be there in the numerator, and this 17 is there in the numerator.
Mm-hmm.
When I'll be shifting it on the other side of the equality, it will get divided. So now it is just a simplification that is required. 17 gets cancelled out with 17 and 15 with 15. So now what I'm left with, that is 1 by x equals to 1 only.
Mm-hmm.
So there are two methods of understanding from here onwards. Like, I need to take reciprocal. 1 over x reciprocal will give me x over 1. And on the right side, it is already 1 by 1. So 1 by 1 is going to be 1 by 1 as well. So the value of x is 1. Or another way could be like, you can understand that 1 over x is equal to 1. You can get it cross multiplied as well.
Oh,
This one.
okay.
1 is being left on the left hand side, and on the right side this is 1 times x. So 1 times x is x, and on the left hand side we have got 1. So the value of x is 1. Again, the same thing. So this is how
Okay.
it has to be done.
Mm-hmm.
And now for question number 7, solve the following equations for x. You see, now the variable x is there in the power or in the exponent. So how it could be solved? The main thing is that make bases same or powers same.
Mm-hmm.
Let it be part A. 3 raised to the power 3x equals to 27. You see the base is 3. So I need to change the base of 27. I need to write it down with base 3. So I know that 3 times 3 times 3, that is 27. So 3 being multiplied with itself 3 times. So that means 3 raised to the power 3. Now you see both the numbers have got the same base, that is 3. So now we can equate their powers. That means the power 3x will be equal to this power. The powers must
Oh,
also be equal. So now this becomes an equation. So the value of x is 3. Shifting this 3 to the other side,